Hello everyone, in this chapter we are going to study loops. So in real world we have encountered loops many a time. Suppose if you liked a new song, then you will listen it to it again and again, again and again. That is nothing but loop. So doing a work repeatedly, doing a particular work again and again, again and again is nothing but loop. So doing a work repeatedly is nothing but looping or loop. So the question is, why do we need loops? So what is the use of loops in coding or in Java or programming, or in programming, why do we use loops? To understand the use of loops, let us consider a scenario that I have given you a question that you have to print system.out.print for one time. So what will you do? You just print system.out.print, and in that you will write hello world. So we have successfully printed system.out.hello world for one time. I want you guys to print system.out.print for 3 times. So you can, what will you do? You just copy this thing and you will paste it again, paste and again paste. You can see that we have printed system.out.print hello world for 3 times. Now my question is it practically possible to print the same thing system.out.print hello world for 100 times or for 1000 times or 1 lakh times? It sounds like, first of all, it is not practically possible. After that, it is not an efficient way to do that. So to encounter these sort of problems, we use loops. So the syntax of loops looks like this. We, in the loop, we'll write the loop keyword. After it, we'll give condition here, and after it, in curly braces, and in the curly braces, we'll write some statements or work, and finally we will give some updation here, and updation will decide how many times this loop is going to run, how many times you are going to print hello world, how many times we are printing hello world, and these condition will check. If this particular condition is true, then it will come into the loop and do all the work which is provided here, and the loop will continue until these particular condition become false. So in Java we have a lot of different kinds of loops, like a while loop, do while loop, for loop, and let us see each one of them. So in Java we have 3 kind of loops: while loop, for loop, and do while loop. And in this chapter we are going to study each one of them, what is the syntax for each loop, and going to do a lot of problems and a lot of examples to understand each one of them in detail. So let us start studying while loop. So the syntax for while loop is, first of all, we will write while keyword. After that, we'll give condition here, and curly braces. In the curly braces, we'll write whatever work we want to do. That work will be executed if that particular condition is true. So the conditions is, we have already studied in the conditional statement, a is greater than b, or b is less than a, or 9 is greater than 3, or 3 is less than 9, or if true, or if false. These all sort of conditions we will give here: a is greater than b, or b is less than a. If this particular condition is true, then it will come into the loop and it will execute all the statements or all the work we have given in that particular loop. So this is the syntax for while loop. Let us do a practical let us do an example problem to understand the while loop even more better. So in the previous question I have told you now, so printing system.out.print hello world for 10 times or 100 times is not practical. Same copy paste is not sounds like it doesn't sound logical, and it is not an efficient way to do that. So for that question, let us use while loop and print hello world for 10 times. So the syntax will be, first of all, we have to write a let us take a count variable, int count is equals to 0, and this count variable will keep track on how many times we are printing or how many times we are running the while loop. So this count will keep track on how many times we are running our loop. So after that, we will write while keyword, while our count is less than 10. So we are printing hello world for 10 times, right? So the condition will be count is less than 10. This is the condition. If this condition is true, then we'll come into the loop and we'll print system.out.print, and in that hello world. So this is the syntax for, this is the syntax. After that, we'll do count plus plus, count plus plus. This is the syntax for writing while loop. These count we initially wrote int count is equals to 0, right? This is known as initialization. Initialization. initialization, and this is condition, and this step is known as updation. So in every loop, whether it may be for loop, whether it may be while loop, or whether it may be do while loop, these three conditions will be present in each one of them. So initialization, condition, if that particular condition is true, then it will come into the loop and do whatever the work. After that, the value will get updated. So remember guys, that if I don't write this updation step, if I didn't wrote this updation step, then my loop will go into run infinite times, and this is known as infinite looping. This loop will continue until our memory will get full, and if memory get full, then we'll get error. So this loop, if there is no updation, then it will run infinite times. So it always recommend, or we should always give updation step in our while loop. So this is the syntax for while loop. The first line is known as initialization. After that, in the parenthesis, we'll give condition, and finally we'll give updation. This is the syntax for while loop, and this code will print hello world for 10 times. Suppose if you want to print it for 100 times, so in the place of 10 you will just write 100, and simply it will print system.out.print hello world for 100 times. So let us dry run this particular code for 10 times. So initially our count is, let us dry run this. So what is dry run? Dry run is nothing but taking pen and paper and checking whether our code is running or not. So it is always recommended that before you press the run button, first of all check how the code will perform using pen and paper. So let us dry run this. So initially our count is equals to 0, and let us consider this is our output screen. This is our output screen. So count is equals to 0. We can see that count is less than 10. Condition is true. So we will print hello world first time, and count will become plus plus. That is, we will increment the value of count by 1. So count will become plus plus. That is, count will become 1. Now again 1 is less than 10. Condition is true. Again we will print here hello world. After that, count will become 2. Again 2 is less than 10. Condition is true. Again we will print hello world, and this loop will continue up to 9, and at count is equals to 9, at count is equals to 9, we will print hello world. After that, count will become 10, that is plus plus, and here we can see that condition is false. So if the condition is false, then we'll terminate the loop, and this is how our code runs. So let us code this thing and understand what will be the output and how the code runs. So in the given question, we have to print system.out.hello world for 10 times to our user. So to do that, let us create a count variable which will keep track on how many times we are printing hello world. So let us initialize it with 0. After that, we'll give while keyword, while our count count is less than 10. After that, in that while loop, we are printing system.out.print, and in that, let us print hello world world. After that, we'll do count plus plus. So this loop will start with a value of 0. Count is equals to 0, and it will goes from 0 to 9, and it will run totally 10 times, and will get output as a system.hello world, and it will get printed for 10 times. So this is the syntax for while loop, and this int count is known as initialization. And after that, count is less than 10 is known as condition, and count plus plus is known as updation. So this is the syntax for while loop. So let us save this thing and run. You can see that we have printed system.out.hello world for 10 times. I told you now, if we didn't give the updation step, then it will go into infinite looping. Let us check whether it will go or not. So I am not writing updation step here, and again save it, and you can see that we will print system.out.hello world for infinite times until our memory becomes full. If our memory will become full, then it will give us an error. So let us run this. You can see that we are continuously printing system.out.hello world for 100 times. So let us stop this code and it is always important to give updation step in our question. If we don't give updation step in our for loop or any kind of loop, while loop, do while loop, any whatever it may be, it will goes into infinite looping. So it is always recommended that we must give updation step. So in this question we have printed system.out.world hello world for 10 times. Suppose if I want to print this code for 100 times, so we will just in the place of 10 I just put 100. You can see that I have printed system.out.hello world for 100 times. So in just 1 2 3, basically in just 3 lines I have printed 100 times hello world. So this is the efficient way, and loops is used to make our code less and make it more meaningful and make it more useful. In the previous question we have printed hello world for 10 times or 100 times using while loops, and we have understood the syntax for while loop, and we have understood what is initialization, what is condition, and what is updation. Now in this question we have to print natural numbers from 1 to 10, so using while loop. So we have to do this question using while loop, and we have to print numbers from 1 to 10. So what is the logic behind it? So the logic and the pseudocode behind this, first of all let us understand that to print number and to count how many times, let us consider that here how many numbers are there? 1 2 3 4 5 6 7 8 9 10. So there are 10 numbers, so we have to print up to numbers from 1 to 10, so totally 10 numbers. So overall we can understand that we have to run a loop for up to 10 times. So let us initialize our initialization variable. Let us consider that int I is equals to 1. After that we will write a while keyword while our I is less than or equals to 10. So we have to run it for 10 times, right? After that, in that while loop we will print system.out.print, we will print the value of I. After that we will do updation step, that is I plus plus. This is the pseudo code for printing numbers from 1 to 10. So let us dry run this first of all and understand how this code works. So dry run, let us consider that this is our output screen, right? So initially I is equals to 1, we will print I value 1. After that I will become 2. After that 2 is less than 10, yeah, condition is true. 2 is less than 10, yeah, condition is true. So it will come into this loop system.out.print I value. Now I is 2, so we will print 2. After that I plus plus, so I will become 3. Again condition is true, that is 3 is less than 10, so we will print the value of 3, and I will increment I by 1, that is I plus 1. So I is here is 3, so 3 plus 1 4, so I will become 4. Again the condition is true, so we'll print here 4, and the I value will become 5, and again the condition is 5 is less than 10, condition is true, we'll print 5. After that I will become 6, and again condition true, 6, and 7, again the condition is true, 7 will be printed, and I will become 8, and again condition is true, 8 will be printed here, and I will become 9, and 9 will be printed, and I will become 10. Now the condition is 10 should be less than or equals to, I value should be less than or equals to 10. So this condition is true, so the condition is true, so we will print here 10. After that I value will become I plus plus, that is 11. Now the condition clearly, that is 11 is not equals to, is not less than or equals to 10, so the condition will become false. After that we will stop our while loop, and we can see that we have printed numbers from 1 to 10. So this is the working of our while loop. So this I is equals to 1 is known as initialization step. Initialization, or I already told you initialization step, and this is known as a condition step. And this I plus plus is known as updation step. Remember, I am telling again and again that if we didn't give updation step in our condition, or if I given a particular condition which is always true, then our loop will go into infinite looping, and it will run up to infinite times until our storage becomes full. So this is the working of our pseudo code to print numbers from 1 to 10. So let us code this thing and understand. Initialize a variable int I is equals to 1. After that we will write while keyword while our I is less than or equals to 10. In that we will print system.out.print I value. After it we will give I plus plus. Save it and run. You can see that we have successfully printed numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how the working of our loop works. I hope you have understood. Now I am going to update our question a little bit. Now we are going to do the same question but in little bit updated question. This is a little bit updated question. Here we have to print numbers from 1 to n, and n will be given by our user. So let us consider that user have given us n is equals to 7. So we will print numbers from 1 to 10, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no, it will get printed from 1 to 7, that's all. And suppose let us consider that n is equals to 2, then we will print 1, 2. If n is equals to 1, then we will just print 1. If n is equals to 10, then we will print 1, 2, 3, 4, 5, 6 up to 10. This is how the question, the understanding of our problem. So in our code, in our previous code, one thing will change, that's all, nothing will change. Here we have initialized a value, right? Int I is equals to 1. So we will run our while loop from I is equals to 1 to up to n value, and n will be given by our user. So the first step will be, first of all we have to take input from our user. So int n is equals to sc dot next int. We'll build our scanner class next int, and we'll take input from our user. This n value will be given by our user. After that, a little change, this is the only change. So int I is equals to 1. We will start our initialization with initializing the value of I is equals to 1. After that, while loop. In the while loop, while I should be less than or equals to, in the previous code we have written I should be less than or equals to 10. Here the condition will be I should be less than or equals to n. So we'll write n here. After it we will print in the while loop system.out.print the value of I. After it we will increment it by 1. So this is the only change. The condition will be changed and n will be taken by our user. N will be given by our user. So this is the pseudo code for our question. So let us dry run this. Let us consider this is our output screen, output window, and initially I is equals to 1, right? Let us consider that n will be given by our user. Let us consider the value of n is 7. So initially what is our condition? That is I should be less than or equals to n. Here n is 7, so I should be less than or equals to 7. This is our condition. If that particular condition is true, then we'll come into our loop and we'll do whatever the work given in that particular loop, and we'll update the value of I again, and again we'll check if that particular condition is true. Then we'll do statements and we'll increment the value of I again, and this looping will continue until our condition, provided condition, become false. So here I is equals to 1, right? So we can see that I1 is less than 7, so the condition is true. So we will print here 1. After that we will increment I by 1, so I will become 2. Again the condition is true, that is 2 is less than 7, so it will get printed on the output, and I will incremented by 3, and again 3 will be printed in the output, and I will become 4, and this process will get continued until our I become a value which is greater than 6, our given condition. That is if I is greater than 7, then it will get the loop will get stopped. So I becomes 6, and 6 will be printed, and I will get incremented 7, and 7 will be printed in the output screen, and now I will become 8, and we can clearly see that 8 is not less than or equals to 7. So this condition is false, and we will stop the loop. And this is our output. Now let us code this our pseudo code in our VS Code editor, and let us see what the output will be. Now let us first of all build our scanner class. Scanner sc is equals to new scanner. In that we will write system dot in. After that, statement terminator. After that we will take n value int n is equals to sc dot next int. Integer value will be taken. After that we will start our initialization step. Int I is equals to 1. After that while our I should be less than or equals to n. If this condition is true, then come into the loop system dot out dot print and print the value of I. After that do I plus plus. So let us consider, let us run this code and let us give I value as 7. So if I give 7, then we have to print numbers from 1 to 7. If I give 100, then we will print numbers from 1 to 100. So let us see, our output will be 1 to 7 numbers. So you can see that 1 2 3 4 5 6 7. If I give n is equals to 100, then we will print numbers from 1 to 100. So this is the code for printing numbers from 1 to n, and n will be given by our user. Now in this question we have to print sum of n natural numbers. In previous questions we have seen we have printed natural numbers from 1 to n, and here we have to print sum of natural numbers up to n integer. Here let us consider that n is equals to 5. So we have to print the sum up to 5. So the output will be 1 plus 2 plus 3 plus 4 plus 5. That is, the output will be 15, right? So what is the logic behind this question? What things we need? First of all, the first thing is we have to take the input of n. That is obvious, right? So we will write int n is equals to sc dot next int. After that, let us initialize a variable called as sum with 0, and sum will track and give us the net sum up to n. So let us write again initialization step. Int I is equals to 1. After that, while our I is less than or equals to n, in that we will do sum is equals to sum plus I. After that we will do I plus plus. Finally we will print system dot out dot print the value of sum. So this is the code for printing sum of n integers, n natural numbers. This is the code, pseudo code. Let us first of all dry run this. By doing a dry run, we can understand what are the things going on in our code. So first of all, let us dry run this. Dry run. So initially sum is equals to 0 and I is equals to 1 and n value is 5. So we have to print the sum of n natural numbers up to n is equals to 5. So we know already the output will be 15. So let us consider that this is our output screen. This is our output screen. So initially sum is equals to 0 and I is equals to 1. We can see that I is less than or equals to 5 here. That is 1 is less than or equals to 5. Condition is true. If condition is true, then sum will become sum plus I. That is, sum is equals to sum plus I. So sum is equals to 0 here and I value is 1. So sum will become 1. After that we'll increment I plus plus. So I will become 2. Again 2 is less than or equals to 5. Condition is true. So sum will become now sum value is 1. Now sum value is 1 and I value is 2. So sum will become 1 plus 2. So sum will become 3. Sum will become 3 and I value will also become I plus plus, that is 3. After that 3 is less than equals to 5. Yeah, condition is true. So sum will become, now our sum is 3 and I is 3. That is sum plus I, that is 3 plus 3. So sum will become 6 and I will be incremented by 1. So 3 plus 1, that is 4. After that 4 is less than or equals to 5. Again condition is true. So sum will become sum plus I, right? So our sum is now 6 and I value is 4. So sum will become 10 and sum value will become 10 and I will be incremented by 1. So 5. And again this condition is true, that is I should be less than or equals to n. Again the condition is true. If the condition is true, then it will come into our loop. So sum is equals to now sum value is 10. So 10 plus I value is 5. So finally our sum will become 15. So sum will become 15 and I will become 6. Now 6 is not less than or equals to 5. This condition is false. If the condition is false, then we'll stop our while loop, and after that we'll print our output here. We'll print our output. So sum value is 15 now. So 15 will be printed as output. So this is the working of our pseudocode. Now let us code this thing and understand how the code works. We have built our scanner class. Scanner sc is equal to new scanner system.end. So let us initialize sum is equals to 0, and this sum variable will give us a sum of n integers up to n, and n will be given by our user. So let us take the n value. Int n is equals to sc dot next int. After it, let us give our initialization. Now initialization step, int I is equals to 1. After that, after initialization step, we will write our while keyword, while I is less than or equals to n. I is less than or equals to n. In that we will do sum is equals to sum plus I. After that, finally we will increment I plus plus, and if while loop is completed, then we will print system.out.print the sum value. Right, save it and run it. So let us give n is equals to 5. We know that if I give n is equals to 5, then sum will be 15. So in the output screen, I will get the value of sum is equals to 15. So you can see that sum is 15. I can again decorate sum is plus, save and run. Now let me give 5 here. So you can see that sum is 15. So this is how the working of code works. In this, we have initialized sum is equals to 0 and taken the value of n from our user, and initialized I value is equals to 1. I value is equals to 1, and this is our condition. I should be less than or equals to 1. If the condition is true, then sum will become sum is equals to sum plus I. After that, we will update our I value. Finally, we will print our sum value we'll get after completing our while loop. So this is the code to find sum of n natural numbers. Up to now, we have studied while loop and the syntax for while loop and initialization step, condition step, and updation step. Now let us study another type of loop, for loop, that is for loop. Now for loop is my favorite one because I use it most of the times, and most of the coders use it for when it comes to loops. So for loop is like more packed and more simplified one. We have seen that in while loop. Let me select my pen first. Yeah, in while loop, initialization step will come here. Int I. After it, we'll write while keyword, while I should be less than or equals to n condition. After that, we'll write some statements here. After that, finally we'll give updation. So we have done initialization, condition, and updation in 3 different lines. So we can say that while loop is more discrete, whereas for loop is more packed and simplified. So when I do most of the questions, when it comes to loops, I prefer to use for loop for most of the times, because for loop is more simplified and packed. So the syntax for loop is, first of all, we will write initialization step and we will give statement terminator. Statement terminator will tell that the initialization step is completed, condition step is completed, updation step is completed. So we can say that after, if we put a statement terminator, then we can say that the particular condition or initialization process is completed. So we'll give statement terminator here. After it, we'll write condition. After it, we'll put finally updation, and if these conditions are true, then it will come into for loop and we'll do some work here. That's all. So in this, we have given initialization step, condition step, and updation step in just single step, in just one line. Whereas in while loop or do while loop, we have done initialization, updation, condition in 3 different lines. So this is more packed and simplified one. So let us do the same question, printing hello world, printing hello world 10 times using for loop. So the syntax will be, first of all, let us write for keyword. After that, let us initialize the initialization variable, that is I is equals to 1, and the condition will be, we have to print hello world for 10 times, right? So we have to run our for loop for 10 times. So I should be less than or equals to 10. After that, we will increment our I by 1. In that for loop, we will print system.out.hello world. hello world. That's all. So this is how the working and the syntax of for loop is. Let us try run this. Initially I is equals to 1. This is our output window. Initially I is equals to 1. uh, the condition is true, that is 1 is less than or equals to 10, right? The condition is true, so we will print, it will come into for loop and we will print hello world. After that I will become 2. Again condition is true, then we will print hello world, and I will become 3. Condition is true, hello world, and these process will continue until we get 10. So finally in the final run, in the final iteration, we'll print up to 10 times hello world. After that finally I will become 11. The condition is false. If the condition is false, then it will come out of our for loop, and finally we have printed hello world for 10 times. So this is the working for loop. Let us code this question and understand the working of for loop. Let me give for keyword for int I is equals to 1. After that I should be less than or equals to 10. After that just I plus plus. In that we will print system.out.print, and in that hello w or ld world. That's all. Save it. We have to give this parenthesis here. Now save it and run. You can see that we have printed hello world for 10 times. So this is the syntax for loop, and I hope you have understood the syntax and the working of for loop. So printing system hello world for 10 times, this is the code, right? So we'll write for and int I is equals to 1, I should be less than or equals to 10, and I plus plus. These step I is equals to 1 is known as initialization step, and this is known as a condition, and this is I plus plus is updation, and I is equals to 1. This I value is known as a iterator, and one completion of particular for loop is known as one completion, one cycle is known as a iteration. So this is the syntax and the theory behind for loop or any kind of loop. So remember that whatever the loop may be, we have three conditions: initialization, condition, conditional step, and updation step. And the initialization variable is known as iterator, and one complete iteration is known as iteration. One complete cycle completion is known as iteration. So here I is equals to 1. Let us consider that this is our output window. So I is equals to 1. The condition given, wait a minute, yeah, the condition given is true, so we will print hello world, and this process will be continued up to 1 2 3. I will be updated, and we will print hello world up to I becomes 11. I becomes 11. If this condition is false, then we will stop our for loop and will terminate our loop. So we have printed hello world for 10 times, and we have seen that dry run previously. So I told you the theory behind the each and every part of for loop and while loop. Now in this question we have to print this square pattern. So this is our line 1, line 2, and line 3, and line 4. So what is the logic behind this, and what are the things? And in detail, and in the upcoming chapters we are going to study a lot of patterns in detail and a lot of complex pattern problems in our upcoming sessions. So in this question the logic is we have to print these pattern for 4 times, and finally if we print all these patterns for 4 times, we'll get our square pattern. So the logic behind is first of all, the pseudocode for this thing is for int line will be start by the value of 1. This is initialization step, and line should be less than or equals to 4. After that line plus plus. In that we will print system.out. How many stars? 1 star, 2 stars, 3 stars, 4 stars. So totally 4 stars. We will print 4 stars. 1 2 3 4, and this loop will run for 4 times. So let us dry run this. By doing dry run, initially line is equals to 1. So the condition is true, that is 1 is less than or equals to 4. Condition is true. Then we'll print these 4 stars here. After that, line will become 2. I want to tell you one thing, that when it comes to loop, the common iterator variables we use is I, J, K. These are the most of the coders use as iterators. So here we have taken line as our iterator. So I line will become, the value of line will become 2. Again, condition is true. Then the second line will be printed and I will become 3. The third line will be printed and I will become 4, and the fourth line will be printed and I will become 5. Condition is false, we will stop the for loop. So this is the dry run and the working of our for loop for this particular question. Now let us code this thing. Now let us take the value of lines, number of lines from your user. So int n is equals to sc dot next int. After that, let us start our for loop for int line is equals to 1, and our line should be less than or equals to n. After that, line plus plus, line plus plus. In that will print system dot out dot print how many stars? 4 stars. So 1, 2, 3, 4. 4 stars. Save it and run. Let us give n value of 4 as 4, and we have printed our output. So this is the square pattern. If we give n is equals to 5, then we'll get our rectangle pattern. Suppose I give n is equals to 10, then we have printed this rectangle pattern. So this is the working and the understanding of our code for this particular question. Now in this question we have to print a reverse of a particular number, and n will be given by our user. Let us consider that n is equals to 10899. Then the reverse of it will be 99801. So this is the reverse. So we have to print the value of reverse for our user. So this is the concept and the question. Now what is the logic behind it? The logic behind is we have to understand 2 steps. First of all, you can see that we are getting the last digit, and we are deleting the last digit. These are 2 important things we have to understand when it comes to reversing of a number. So we are getting the last digit and we are printing it. After second last, third last. After that 0, 0, 1, 1. So we are getting from last to first. So to get the last digit of a particular number, we use modulo operator. Remember, so there are 2 conditions. To get last digit, we'll use modulo operator. We'll divide that particular number with 10. We'll use n modulo 10, and this will give us the last digit of that particular number. And second step will be to remove the last digit. Suppose let us consider that here n is equals to 10899, right? So first of all we have to print 99801. This is the reverse of our particular given number. So first of all we have to take this 9 and we'll print here. After it we'll delete. After that we'll take our second 9 and we'll print here. After it we'll delete. After it we'll take 8 and we'll print here. After it we'll delete. And after it we'll take 0 and we'll print here. After it we'll delete the last digit. The last digit will delete. So this is the working. So to delete the last digit of a particular number, to delete last digit, we will do what? We'll do n is equals to n divided by 10. So to get the last digit, we'll modulo it with 10, and to delete or to remove the last digit of a particular number, we'll divide it by 10. So remember, these are the 2 things we have to understand for doing this question. So the pseudocode will be here. First of all, we'll take n value, int n is equals to sc dot next int. After that, what we'll do, we will start a initialization here. This is itself initialization step. After that, we'll write our while loop while our n is greater than 0. In that, we will print system dot out dot print our last digit, that is n modulo 10. Finally, we'll do n is equals to n divided by 10. This is our updation step. So this is the working of reversing of a number. Now let us dry run this first. By doing a dry run, we can understand what is going on your code and what is the logic behind it. So first of all, n is equals to 10899, right? So n is equals to 10899 is the value given by our user. After that, we can see that condition is true, that is n is greater than 2, condition is true. Let us consider that this is our output screen. Here we will print our reverse of a number. So we will print n modulo 10. So I told you now that to get the last digit, we'll modulo it by 10. So what this value give? This value give this last integer. So n will this value will give 9. So 9 will be printed here. After that, n will become n divided by 10. N divided by 10. That is 10899 divided by 10. So n will become now 1089. So the last digit will get deleted. After that, again the condition is true, that is n is greater than 2, condition is true. Now we will print n modulo 10. Now the last digit of this is 9, again 9. So n will be n modulo 10, that is 9 will be printed here, and now n will become n divided by 10. So the last digit here will get removed, that is now n will become 108. Again this condition, that is n is greater than 0, is true. Now we will print the last digit, that is n modulo 10, that is 8 here. So 8 will be printed, and we will do again n divided by 10. So this value 8 will get deleted, and now our new n will become 10. After that, we will do n modulo 10. Now again condition is true, n is greater than 0, condition is true. After that, we'll get last digit as 0. Yeah, 0. After that, n will become n divided by 10, that is 1. This value will get deleted. Again n is greater than 0, condition is true. Now the n value is 1, n modulo 10. So finally we'll get this last digit 1, will print here. After that, now n divided by 10. So now n will become 0. This condition, that is 0 is greater than 0, is false. So we will stop our while loop, and we have seen that we got our output as a reverse of our number. So let us code this. By coding this, we will understand it even more better. So we have taken our scanner class. After that, let us take the n value from our user, sc dot next int. After that, while loop, while our n value is greater than 0, in that we will print system.out.print n modulo 10. We will remove ln, n modulo 10. After that, n will become updation step, that is n divided by 10. Save this and run. Let me give n value as 10899. So we will get output as 99801, the reverse of this number. You have seen, we can see that the output is 1099801, the reverse of our given number. So this is how reversal of a particular number works. Now let us talk about our third kind of loop, that is do while loop. Do while loop is we can do the same work using any three of them. The work will be same, the only difference is syntax. So here in the do while loop, we will write do keyword. After that, in curly braces we will do some work here. After that, first of all, here initialization step will come here. We will give initialization here. After that, do keyword, we will do some work here. After that, in the do keyword itself, we will give updation step I++, and this is our condition. We will close the curly braces and we will write while keyword, and in the parenthesis we will give condition. So let us do the same question, printing hello world for 10 times using do while loop. So printing hello world for 10 times using do while loop. So the question syntax will be, first of all, we'll write int I is equals to 1. This is initialization step. After that, we will write do keyword do. After that, the work will be here, system.out.print hello world. After that, updation step I plus plus. After that, close the curly braces and write while keyword while our I is less than or equals to 10. So this is the pseudo code for our do while loop. So we have already done the dry run for this particular question. So again, let us do a little bit of dry run using for the syntax of do while loop. So initially I is equals to 1, right? Condition is true. The condition will be checked here in the while keyword. So condition is true. So we'll print this. Let us consider this is our output screen. We'll print hello world here. After that, we'll increment I by 2, and again condition is true. Again these uh, looping and this iteration will continue until the value of I will become 11. So we have printed hello world for 10 times. So let us code this thing and understand it. Now we have created our scanner class and n will be given by our user. So after that, we'll write do keyword. In the do keyword, we are printing system dot out dot print. In that, we are printing hello w o r l d hello world. Before that, we have to initialize, right? We have to use our initialization step. So int I is equals to 1. This is our initialization step. After that, in the do keyword, we are printing system dot out dot print. After that, finally updation step, curly braces close, curly braces close. After that, while keyword, in that we are giving condition I should be less than or equals to n. Save it and run. When I run this, we have to give we have to put a statement terminator here, right? So let me put statement terminator, save again and run. Let me give n is equals to 10. So by giving 10, we will print system.out.hello world for 10 times. So you can see that we have printed hello world for like 10 times. So this is the working of do while loop. And I want to tell you one thing that in most of the questions we do in real world problems, like when you go to lead code or hack rank, these coding kind of platforms, you use for most of the times you use for loop, or in some scenarios you will use while loop. And do while loop is like most least used loop in three of them. And in some questions, in theory questions or in exams, teachers may ask about working of do while loop in many of the schools. So understanding do while loop is better, is good, but in most of the questions we don't use it that much. In previous classes I told you now, break and continue are known as jump statements. Break and continue, let me change my ink here. Yeah, break and continue are known as break, continue are known as jump statements. Jump statements. So if you want to skip a particular iteration, or if you want to get out of the loop, if a particular condition is true, then you want to get out of the loop. To do that, we'll use break statement. So break statement is used to exit the loop, and continue statement is used to skip a particular iteration. So let us understand the working of break and continue by using a sample problem. Suppose I want to print numbers from 1, 2, 3, 4 up to n. I want to print natural numbers from 1 to 10. So we have already seen the question and the pseudo code and the code, all those things, and we have already did the dry run for this. So the code will be for int I is equals to 1 and I should be less than or equals to 10. After that, I plus plus. In that, we are printing system.out.print the value of I. So this is the code for printing numbers from 1 to 10. Suppose if I value is 4, then I want to break out of the loop. If I become 4, then I want to exit from my loop. To do that, we'll just write, let me erase this thing. Erase. Yeah. So to do that, we'll write here in the for loop, if I is equals to 4, then we will just simply write break keyword. That's all. Break statement terminated, that's all. And after that we are printing I value. So this is how the loop for printing numbers from 1 to 10 will work. Now here is if I value is equals to 4, then we'll terminate the loop, right? So let us try run this. So I is equals to 1. Let us consider this is our output window. Output window will print the value of I. 1 will be printed, and 1 value will get again incremented by 1. So I value will become true and will print 2 here. After that again 3, 3. After that I will become 4. If the I value become 4, then we'll terminate the loop. So if I is equals to 4, then it will come out of the loop, and that's all. This is our output. Suppose if I want to skip a particular iteration, then in the place of break I will write continue. If I wrote continue here, then let us see what will happen. So initially I is equals to 1, right? So I is equals to 1, the value will be printed here. After that I will become 2, 2 will be printed here. After that I will become 3, 3 will be printed here. Now I will become 4. If I is equals to 4, then what I am doing, I am skipping that particular iteration. So 4 will not get printed here. 4 iteration will get skipped. So I will become 5, and 5 will be printed here. I will become 6, 6 will be printed. 7, 7 will be printed. 8, 8 will be printed. 9, 9 will be printed, and 10, 10 will be printed, and 11. Finally condition is false, then we'll stop the loop. So you can see that at the 4th iteration we have skipped particular iteration, and we haven't printed the value of 4. So this is the difference between break and continue. So these two things, break and continue, are known as jump statements, and break is used to terminate or to exit from particular loop if particular condition is true. If you want to skip a particular iteration for a particular condition, or for a particular given condition, to do that we'll use continue statement. So we have going to print numbers from 1 to 10. So int I is equals to 1. After that I should be less than or equals to n I plus plus. In that we are printing int I is equals to 1. After that I should be less than or equals to 10. After that I plus plus. In that we are printing system.out.print value of I and value of I, right? So if I is equals to 4, then what we are doing, we are just writing break. What will break do? It will exit the loop. So let me see that. So our output will be 1 2 3, that's all. So run this. You can see that our output is 1 2 3, and if I becomes 4, then our loop will get terminated. Suppose in the place of 4, in the place of break, I will write continue here. Continue, save it, and again run. You can see that 1 2 3 and 4 is not printed. So the 4th iteration got skipped. After that 5 6 7 8 9 10. So to skip a particular iteration, we'll use continue. To exit the loop, we'll write break. Now in the given question, we have to tell whether a given number is prime or not. So what is the logic behind it? In maths, we know that a prime number is a number which is divisible by only 1 or itself. It is known as a prime number. So we can basically say that a prime number is a number which is not divisible by any other number except 1 or itself. It is known as a prime number. So in maths, we know that a prime number only have two multiples, that is 1 or itself, right? That is, we can simply say that no other multiples, or it is not divisible by any other number except 1 or the number itself, that is n. Let us, if say we the number is n, then it has only two multiples, that is 1 or n. So we can say that the given number is not, if the given number is not divisible by any other number except 1 or 7, then 1 or that particular number, we can say that the given number is a prime number. If it is divisible by any one of the any number, then we can simply directly say that the given number is not a prime number. So let us consider that to understand the logic behind it, let us take a scenario that the given number is n is equals to 7. So we will check. The first step is checking divisibility to check that we run a loop. We will run a loop, and in this question we are using for loop. So we will run a for loop in this question. And the second is checking. The second step is, first of all, we run a loop, for loop, and in the for loop we are checking it is divisible or not. Is it divisible or not? Divisible or not? If it is divisible, then we immediately terminate the loop and we will say that given number is a not a prime number. If it is divisible, then we can directly say that given number is not a prime number. If it is if we check if we did check all the numbers and the given number is not divisible by any other number, then we can write, or we can imply from that the given number is a prime number. So this is the logic behind it. So in our scenario we have taken n is equals to 7, right? So we know that 1 is divisible by all numbers. So we'll run our for loop from 2. So for int I is equals to 2. What did I tell you? That a prime number is divisible by 1 or itself. So we know that a given number, a given prime number is divisible by itself or 1. So we'll run our for loop from I is equals to 2. I will run our iteration from I is equals to 2. After that we will run our loop up to I is less than n. After that I plus plus. In the for loop we are going to check if the particular number that is n modulo I is divisible or not. If it is divisible, then we'll get remainder as 0. Then we can simply say that is prime is equals to false. After that, if it is not, then else case, else is prime is equals to true. And one thing more here, that in the if statement we will write break. If it is divisible, then we will give is prime is equals to false, and immediately we will terminate our loop, right? This is the syntax. And before here we are going to create a boolean variable, that is prime, and is prime will tell us is prime will only stores two values, either true or false. So we are initializing a boolean type variable is prime is equals to false initially. After that, finally we are checking after completing for loop all the iterations, we are checking if is prime is equals to true. If is prime is true, the value of is prime is true, then we are printing system.out.print prime number, right? In the else statement we will print system.out.print not prime. So this is the pseudo code for our code. Now let us try run this same code for n is equals to 7. We already know that the given number n is equals to 7 is a prime number. So first of all, initially n is equals to 7, right? And initially our iterator value is 2. So we'll check 7 modulo 2. One more thing, that we have initialized is prime is equals to false. So these are the initial stages, right? After that we are checking 7 modulo 2 is not equals to 0. So is prime is equals to, it will become true. After that again 7 modulo 3 not equals to 0. Is prime is equals to remains true. So from false it will become true, right? 7 modulo 4 is not equals to 0. Similarly 7 modulo 5 is not equals to 0, and 7 modulo 6 is not equals to 0. Now I plus plus, right? So I will become 7 and this condition will get false and will stop the loop. Now the value of is prime is true, right? So if this value is true, then we'll print given number is a prime number, else we'll print not a prime. So I hope you have understood the dry run and the pseudocode and the logic behind this question, that whether given number is prime or not. Now let us code the same thing here in our code editor. And first of all, let us create our scanner class. Scanner sc is equals to new scanner system.n. After that let us take n value. Int n is equals to sc dot next int, right? After that we are running a for loop. Before that we have to take a boolean value, right? Bool, yeah, okay. Boolean is prime is equals to, we are initializing with false, false, false. After that we are running a for loop. So for int I is equals to, starting with 2 and I should be less than n and I plus plus. In the for loop we are checking if n modulo I is equals to 0, then we will set is prime is equals to false. After that we will immediately terminate the loop, so we will write break. Else, in the else statement, else is prime is equals to true. That's all. After completing the loop and all the iterations, finally we are checking if is prime is equals to true or not. If it is true, then we will print system.out.print given number, prime number, prime number, prime number. Given number is a prime number. Else, in the else statement, else we will print system.out.print not a prime, not a prime. That's all. Save it, save this and run. So first of all we have to give our n value. Let us give n is equals to 7. We know that n is equals to 7 is a prime number, so the output will be prime number. Now let me give n is equals to 10. We can see that not a prime number. So this is how we will tell whether a number, given number, is prime or not. So initially we have created our scanner class. After that we have taken the value of n from the user. After that we have created a boolean type variable is prime and we have initialized it with false. After that we have started our for loop with I is equals to 2 up to n, up to I is less than n, and incremented by I plus plus. In the for loop we have checked if that particular number n modulo I is divisible by any other number, that is I. If it is divisible, then we have immediately of is prime is equals to false and have terminated from the loop. If not, then we set is prime is equals to true. After completing all the iterations, finally we are checking is prime is equals to true or not. If it is true, then we will print given number is a prime number, or we will print a given number is not a prime number. So this is the code, and a code for checking whether a number is prime or not. So here's a catch. The given code here is not efficient code for checking prime or not. So I want you guys to go into Google and search prime checking prime number efficient code, or which has less complexity and space complexity. So I want you guys to understand the efficient code yourself. In upcoming classes I will tell you, but for now this is not efficient code. Suppose if I give n is equals to 1000, then it might take long time, and we are running loop from I is equals to 2 up to n, so the total number is n numbers. So it is not a efficient code. We are checking for n numbers, so it might take long time. And in future classes we'll study about efficiency of code in terms of time complexity and space complexity. It's a separate chapter, but I want to tell you guys that this is not efficient code. This is like a brute force approach. What is brute force approach? Brute force approach is nothing but going with the intuition, going with the first logic we have ever come across. So this is a brute force approach we have done. Now I want you guys to go into Google and type efficient code for checking prime numbers. I want you guys to copy or type efficient code for checking prime numbers and try to understand it yourself. It's okay if you didn't understand, but you checked yourself. You did go into Google and searched on yourself. That's a good thing. So with that being said, in this chapter we have covered 3 types of loops: while loop, do while loop, for loop, and we have done a lot of examples like printing natural numbers up to n, printing sum of natural numbers, reversing a number, prime numbers, and all those things. Now I want you guys to do the assignment which is provided after chapter completion, and first of all do the assignment. After it, compare the solutions which is given in your solution set. With that being said, I will see you in the next chapter, and the next chapter going to be like a little easy and at the same time very logical and very interesting, and the chapter name is patterns. So I will see you in patterns chapter.